and we'll start. Okay, we'll just start. In the meantime, for those of you who have joined today for the first time, welcome to this WIDS Datathon workshop. I'll just quickly give an introduction about WIDS Mumbai. So to introduce myself, my name is Khushbu, and I would be the host for today. WIDS Mumbai as an independent event started in 2018, and this is the fourth year we as WITS ambassadors are conducting this conference. It aims to inspire and educate data scientists all over the world, regardless of the gender. For 2021, WITS Mumbai, along with WITS Kerala, have planned a data tech series for 5 days, which will be covering different topics, and it'll help you to participate in the Global WITS Datathon. Uh, Today, it's the day 2 of the workshop, and we have Julian Joseph, who is a full stack engineer helping to develop products which would aid in improving the healthcare system. Julian is also the founder of WITS Mumbai and WITS Kerala. So today she would be talking about the exploratory data analysis and its technique and the critical functions involved in it. So uh, over to you, Julian, for starting the session.
Thank you. Thanks, Khushbu. So just before we begin, a bunch of you had doubts on how do we form teams. So I would like to just remind you, we have this sheet that we are maintaining for everyone who's attending the workshop. And yesterday I missed adding, and I think Usha had also mentioned, I'm not sure, the one rule that this datathon for WIDS has is your team has to be formed with a 50-50 ratio. That is, you need to have 50% of your participants in your team. A team can consist of 4 members, and 2 of them have to be those who have identified as females. So in the column, in the sheet that we had shared yesterday, we have added a column that says gender. I have added F against people who I thought was are women. So others, I would request you all to just add your genders there, and we can. The suggestion that I have is do sign up, create a team yourself, begin with the creation of a team, name your team something, and once you have that, add the team name here, and you can send each other team merge requests. Once you do that team merge request, it's simple. It's just like saying a friend request in Facebook. You can merge teams once you have that consistency. Like supposing you have, say, 3 of you from here have created teams. 2 of you can contact either in the WhatsApp chat itself or in the sheet itself. You can say these two can merge together, and hence you can just create a team. But there is no restriction on the fact that you can't be a solo participant. So I would urge all of you to just, if you have created the Kaggle account, go ahead and give your team name, like team, then write your name, and that's it. Like, give a name and then just join the competition, so that whenever there's another person as a team, you can just join that. Okay. Having said that, let me just share my screen. Are you able to see the? Is everybody able to see this Kaggle notebook? Could somebody unmute and tell me?
Yeah, I can see.
Okay, so Karthika, could you just share the link of this, or should I be able to do that? Where is chat? This is the link. I would like you guys to just open this on your systems as well, considering the fact that you should have signed in via a laptop. Is this chat? I'm not able to share this. Where is chat? Oh yeah, here. Okay, so this is the Kaggle notebook. Just click on this and we can follow along. You can go ahead and click on copy and edit on the top. I am able to see a save version here, but you should be able to see copy and edit on the blue bar here. Once you're able to see that, click on copy and edit, and then where my name, Julian Joseph, is coming, your name should be able to come there. So you can now, inside your Kaggle user, you will have a copy of this notebook. This is a Kaggle notebook. You should be able to click on these cells, edit them also in your version of it, and run those cells, because we're going to program today, right? Having said all of that, we have the agenda for today, as you must have read in the Google Doc as well. The agenda includes problem-solving techniques on general. There'll be a general understanding of what an ML lifecycle looks like, and when do we use regression, when do we use clustering or classification. For any of you who are new to this, I'm hoping I will be able to give you certain concepts and some things that you would have to further Google and understand, or I'll definitely hand over the resources that I've used, the books that I've referred, all of that will be provided to you. And since I think a lot of you are already really smart and have been in data science for a long time, if it feels redundant to you, I'm really sorry, bear with me. But I'm considering complete newness as well, newbie level as well, compared along with the experience level. I hope even for the experienced people, there will be something fresh to take away. So let's dive right in. The agenda looks, the second thing we'll be having is, of course, EDA. Third is the univariate and bivariate analysis, along with a bunch of case studies. I have a few data sets that I've taken, and I'll also show from where I've taken these data sets. These case studies will be handling today. And we'll end with data set cleaning strategies. There are several of them. We'll be discussing a few of them. Okay. So I'm hoping, just give me a thumbs up if you guys can actually see the notebook. And everybody's ready with the notebook, right? If there's anybody who's having struggle with any of this, feel free to ping on the chat. We will help you out. There are a bunch of WIDS ambassadors in the chat here, as well as in YouTube. We will be monitoring all of this and we'll help you out, okay? So as data scientists, even before the datathon, after the datathon workshop is over, when you guys graduate as students, a lot of you are students in colleges currently understanding this. For you all, I would definitely like to explain these different stages that come into each and every POC, proof of concept, that you would take up, or if you have been asked as a statistics consultant, if you're asked to give your inputs on, suddenly there might be a client that comes in and says, okay, build a chatbot, use AI for this product. But before you jump right into taking the data set, making a chart out of it, or putting an algorithm, a named algorithm from somewhere, and just building that model, you have to understand the problem definition. So you will have to have those conversations with the clients or whoever is bringing this thing up to you. In our case, it's a datathon, so we already have a set of rules. We already have a set of objectives for the sake of this competition, so that people can understand how to use data science. But in the real world, after the competition is over, you would also have you would have to have those difficult meetings with them and understand, why is the client asking us to do this? Why is this thing actually valuable? You will have to understand and define that problem in your own, so that you can understand what I have to do when, and prioritize. Also remember, you also get a stipulated time period. Even when you're working, you'll be asked to do certain things. So your decisions that you take would not only be on where do I get the data from, or what kind of pre-processing things I have to do, or how I transfer my model. It might also be on how much can I finish within the certain time limit I've given. So you have to take a lot of decisions as a data scientist. And at every stage, once you have defined the problem, you move into data selection. Now, so all around us nowadays, supposing all of us see, when we type something into Google, their suggestions have improved so much. How has that happened? Because they have been collecting data. How during November, they know Indians will search for Diwali lights. Why? Because they have been collecting data for so long, and as they collect data, they have improved their algorithms by training their algorithms on these new data sets, data points that they keep collecting, right? And all throughout this, what happens is, when you select that data, you need to make sure that it is coming from an authentic source. So for the datathon, we know it's coming from MIT. We know we can trust that data. There is there's no incorrect data that will be given to us. And these data sets that I'm going to be using here are also competition data that are produced that have been given to us in Kaggle itself. One of the competition that we're looking at is a prediction competition data set, and this is a competition, so you have sufficient information on what the data looks like and how it is. But there are other things from Kaggle that I've taken is World Happiness Report. This is a data set. So there's a difference between a competition and there's a data set. Inside a data set, you won't have an objective. It's just a data set, and you can use it for learning purposes or for other competitions. But in a competition, you will have an objective. The problem statement is defined already, and you will have along with this, what data set you have to use for that, the train and test data will be given to you, right? So moving back to my notebook, so once you have that set of authentic sources, that is when you make the decision, chalo, let us put in efforts for doing EDA. Just don't just jump in right in and say, let's spend 2 hours building lots of different data visualizations. It's fun and all, but then if the data is incorrect, there's no point in going forward, right? So make sure of that is correct. Now, data exploration with the data is basically our means to understand what kind of data exists. Is it categorical? Is it continuous? What does our target variable look like? How does that target variable compare with the other variables that are there? Now, for people who have no idea what I'm talking about, let's just look at this competition data. So as it says, you're trying to predict sales prices. So you have a bunch of house prices mentioned, and we will be like, what is our target here is the sales price. So here, when we look at this entire thing, already we have defined that sales price is your target variable. Okay, and everything else, these are all variables. It is up to us to figure out whether it is a continuous variable, which means they are numbers, or categorical variables, which means they could be ordinal numbers, they could be nominal, as in they are numbers, like anything that's binary or A, B, C, D, grades, those are all categorical variables. And along with that, they are so helpful in this case, where they have actually defined the entire thing. So every variable that you see, when you download this trained CSV, it is going to, we'll jump right into, don't worry, it's not going to be a complete theoretical class. We will be seeing this entirely. So the exploration of this data set actually, you will be drawing graphs, yes, but the objective of drawing graphs is to understand this relationship of the target variable, whatever is the objective. Currently, we're focusing on predicting the sales prices, the relationship of that variable with the other columns. There could be gazillions of columns, right? You can't just keep working on every single thing. So that's one part of this. Let me just also show you some things before we tell you this example. So depending upon the problem, here it's prediction. And therefore we are going to be using regression, but it could be different things. You could you have to make the decision whether it is a supervised learning or is it an unsupervised learning. And very often these small categorization actually helps. If you want to find out whether your final answer is going to be a number, most often than not, it's going to be regression. And if it's a class, whether it's a cat or a dog, that's a classification problem. And sometimes you would have more than two, so it'll be a bunch of groups, so it'll be a clustering problem. And these decisions, once you've made that decision, is when you start understanding, that's when you jump into creating that model. But that decision has been made earlier on, and we'll keep iterating over this a little bit. This is one example, one of the first examples that you see in the book ISLR, which is one of the must reads for every data scientist, aspiring ones at least. Introduction to Statistical Learning, that's in R, but you also have Python versions of that available in GitHub. So what you see here is it's a basic marketing intelligence problem where we are trying to, as statistical people or data scientists, you would be say asked to find out whether the advertising budget is has to be allotted for TV more, or for radio more, or for newspaper. So for example, you buy a phone. Okay, you might actually buy that phone make that decision to buy the phone based on the ad that you saw on TV, or maybe the ad that you heard on the radio while you were driving your car. So you don't know what actually led to that decision, but there are people who can figure that out using the data, right? Every company sets aside a certain amount of budget for each of this, and this is a regression line that is being plotted against what drove the sales. Along with, so the sales is what we are trying to compare with our TV budget, the amount of money that we put in for our TV advertisements, or for the radio advertisements, or for the newspaper advertisements. Okay, please do ping me if I'm going too fast, but there's a lot to cover. So this is a simple regression problem, but along with the simple regression, which looks like a linear y is equal to mx relationship here. So y is equal to mx, I'm hoping everybody here has a small background of maths. And there was a prerequisite document also circulated before the datathon. So y is equal to mx is the linear regression model. This line that you see can be defined as y is equal to mx, right? And y is your dependent variable and x is the independent variable. But then this m decides the slope of this, how far it should be sloping. Okay, now multiple regression case, you might have x1, x2, x3 all the way. You might have more than one variable on which, independent variables on which your y is dependent. Okay. Yeah. Now there could be a case where your data set is really huge and it might not there are a lot of cases where people say AI products banane hain, but linear regression se hi kafi kaam chal jata hai. If not, even with logistic regressions, a lot of the work can be done. So the company I'm working for right now is having sleep apnea data, and even there to predict whether a particular patient is going to use the inhaler device that is being prescribed to him by the doctor or not, we are using logistic regression. It's not hi-fi AI, but it is data science. It is statistics. And logistic regression is something that it's a special case of linear regression, but it helps you get those two classes. Your end result would be categorical. The output variable would be categorical. And one fun fact is that it applies a non-linear function, sigmoid function of it. So it's like a tiny instance of neural network. I'm not defining neural networks a lot here, but we'll be having that on our day 4, I think. So do continue coming to these sessions because neural networks is very exciting. We could spend some time here on this. But do remember these small things when we start learning about this, right? What else? Yeah, the other decision that you can make on is, as I mentioned earlier, whether supervised learning data or this thing is based on whether you have a label data available to you or not. So like we saw in the house prices problem, we here in this case we are predicting the sales, right? And in some cases you might have, say, cat and dog classification. Now you need to have like a bunch of say thousands and or maybe tens and thousands of cats being fed into your model for it to actually know what does a cat look like, right? You need to have a set of label data, but it's not always true. Sometimes you might end up having no label data. So very often we see interns being hired in companies to label the data. I'm telling you what happens inside, but what I'm trying to explain is sometimes human intervention is required to label the data, and then you feed that label data back into your training part so that you can then send it to the model for training, and then you can actually get more results. The more data your model sees, it gets trained better. And what models are, how to build those models, we're going to learn in the next class. I'm just giving you a brief one-liner introduction to all of this because these different stages do exist in our pipeline of any ML, any time you build a product or you this thing. But what you need to understand is there is a bigger picture always. And as data scientists, when you walk away from this workshop, know that you need to ask these questions. Why am I having this kind of a data, or am I getting the right data? Before you jump into EDA, make sure you have these questions. Learn to ask why and see the bigger picture from outside. Okay, this is where the data was collected from. Maybe air pollution data is being collected. BMC in Mumbai is collecting data, or Kochi municipality is collecting data. Where is this effort being put in? Is it being labeled correctly? Who is doing this? You need to make sure that you are aware about all of these things. A good data scientist is built when you keep yourself abreast about all of these things, not just deep diving into, I mean, of course you have to have math and stats, but also have an understanding on what is the business side of this, as well as what happens on the ground level as well. In terms of the clustering problem, like I mentioned, here you've come in logistic regression. There were 2 classes, but you could also have more than 2 classes where you have these clustering algorithms. So in this, what you see here is that sometimes whatever patterns that you learn, so most often than not, your data set will most of the variables will follow a pattern, but there'll be some values that just don't follow a pattern. Like I mentioned, continuous variables are numbers. Categorical variables are they are basically alphabets, or they could be 0 1s binary values. But I have worked on cases where categorical variables are also 1 or 2. Say flows, okay? One client, a retail client that we had was having a categorical variable called floors. So number of flows is 0, 1, 2, 3, right? It's perfect. It perfectly makes sense. So do not go into any problem saying that, oh, it's a categorical variable, it will never be a number. That is also not true. So there could be outliers in every case, and whenever there are outliers, they are called anomalies, and these anomalies will not fit into any clusters. If you try to make any clusters, sometimes there will be outliers. Regardless of what you do, you will end up having something or the other as an outlier. And there are companies who actually work on just finding out outliers. We'll get to more outliers once we get into our house prices case study. Okay. Moving on from neural networks, deep learning, which will happen on day 5. There's also called something called RL, which we hope to introduce to you more in a lot more detail through one of our talks. So stay tuned. But what happens in introductory level, what happens in a reinforcement learning is you would have a particular agent who tries to figure out without having any supervision from human beings, make mistakes, get penalized for the mistakes, get rewarded for the correct things, and then keep learning without any training data set. The agent itself learns from experience. It's like a child. It falls, it gets up again, and then it tries to do better the next time. So as you graduate and as you learn this a lot more in detail and understand how a multi-agent works, how a single agent works in an environment like this, there is this very fun video that I've linked in this notebook, which you should definitely try watching, where there have been researchers who have actually tried to train models into playing hide and seek, as you can see here, and the red ones have to actually try to attack the blue ones, and the blue ones are trying to find the best ways to protect themselves. So it's a fun video. It's being made by OpenAI. There's a paper on this, but do check it out. Like, I'm trying to introduce you to things that are fun also in data science, not always sales and serious stuff like this. It can be fun things like this as well. So do check it out. But now that you've understood the importance of this, there's also so where were we on the stages? I think we have covered most of the stages. So data processing will happen, feature selection, model selection. And once you've figured out on what model selection, what model you've done, what training you should be, how long you can train for it, how well you've gotten the data to train for it, you might have to ask yourself some questions before you deploy it. That comes into the model evaluation stage. In this stage is where so this is like when you've implemented certain machine learning algorithms, you do know like some algorithms will work on some data sets, some might not, right? And your best solution you will actually figure that out with experience on which one works best with what data. But you can always, once you've made the model, like how Usha was showing yesterday, the leaderboard actually keeps changing, right? When you keep submitting on this thing, and that the way these people do multiple submissions is by trying to improve the accuracy of their model, trying to improve maybe the scalability of their model. Now, in terms of scalability in real world applications, you might have more understanding. You might have to spend more time on making sure this is scalable for maybe you're building a B2C product where B2C is business to consumer, like Zomato. Zomato is a B2C or B2B. Like scalability depends on the usage of that final product. But you can also question yourself on how long does it take to train your model or test your model. You can keep iterating over this. If you remember seeing that arrow that goes, when you evaluate, here is where you can keep iterating over this thing. Sometimes you might feel what you've selected is wrong and you have to go and change something. You might have new data sets being added, like how Usha mentioned yesterday. And you might have to go on doing this for a long time before you finally go ahead and say, okay, I am happy with the accuracy. I'm happy with the time that it takes. I'm happy with the fact that it can scale for so many customers and it meets all of my clients' requirements. Once all of that is done is when you move and progress towards the deployment. And Shweta, for the next talk, will be taking validation strategies also pretty much in detail. Just on a very basic level, what I can tell you is this, that before you jump into creating all of your models and all of this, very often the practice followed is you split the data. But in case of our competition, when we come into our competition, we are given training data only. So we don't usually do this, but we can definitely go ahead and split the training data also into, in this case, like 70% training, 30% for testing. Now, some people actually try to keep some out further from that, as you can see in this train, test, and hold out. So they'll train the model for this much amount of data. They'll test it on this and again on this. So the one problem that keeps coming in all of this splitting is the sampling bias, where sometimes, say, some people who like chocolate ice cream are present in this, but there are no people who like chocolate ice cream present in the test data. Now, that is a sampling bias. Sometimes there is a lack of certain kind of data in that testing system. You can't help it. So for avoiding such sampling bias, there are a lot of strategies, which Shweta will be taking in detail. They're just called, I'm just mentioning the names here. k-fold cross-validation, leave one out cross-validation, and there are a bunch of things mentioned in this link here. So do go ahead and check out this blog. And hopefully, after having followed all of this, you are satisfied with all of your answers and you can go ahead and deploy. Now we're moving on to our EDA. So EDA basically was something that we have been doing for most of these things, but like Usha had mentioned, there are very simple ways to go ahead and do this. And you might actually go and look at somebody else's EDA for the same data set and just skip the step. But what the objective of this entire process is, you are able to spot the patterns that your variables follow. You can find out if there's any missing data, if there's any error in your format of the data. And then you can basically build assumptions or check your assumptions and create that hypothesis of, okay, this is how this is going to be, and make use of and create a model that makes use of your minimum, you can focus and zoom into those most important variables. So we have two kinds of analysis, univariate and bivariate. Univariate is basically going to be of these four types. We'll have frequency distribution tables, we'll have bar charts, histograms, and something that everybody hates, that's pie chart, because it's really hard to understand, but we'll try to make it fun here. Then we have the bivariate analysis, which is going to be scatter plot, box plot. I've not done a mosaic plot, but this is also possible. And then, of course, there is multivariate visualization that can help, but in terms of understanding how that entire interaction is happening. Okay, so I am also giving credits to Pedro, this PhD person who has actually helped me build this. So credits have been given. We should follow these ethics. Now, I'll just walk into the house prices thing, right? So one thing that you can always go ahead and do is this. You have the data here, and I'm going to be using train.csv. Now in Kaggle, they have been so kind enough to help us out and see, like I mentioned, they have given the definitions of everything here. They have given definitions of, say, what is the overall condition of the house. I'm going to buy a house here, but I'm to have to predict the sale price of the house, right? Which is our target variable, like I mentioned earlier. And the year built. So year built is going to be the original construction date. They've defined every single variable that will exist in my train.csv that we are going to be using. There's also total square feet of basement area. So if you see total BSMNG it means this, right? I'm just focusing on things that we will be using. Garage cars, the number of cars that can come within your garage, and the garage area, so on. But what is fun here is the Kaggle node competition itself gives you this. It gives you the graph of how this looks like. So when we see our histograms being plotted, this will make sense to you. Okay. So do go ahead and check out this for any competition. Read the rules, along with that, read all of the data, and then see and play around with what all is available within Kaggle before you jump right in. So we have imported a bunch of libraries here. Okay. And this is how. So one thing I felt yesterday, so a lot of you had asked about directory problems. So what I do basically is click on this copy file path. Once I've added this, to add the data, all I did was add data, and then I went to that particular, I found that via the URL here. I found house. If I just click on, say, house prices, type house prices here, I should be able to find that if it's not house prices. But basically, you'll have a lot of data sets that you can find via the URL here. If you have the URL, you can directly search by that, or search, say, World Bank, not, yeah. So you have like World Bank data. I can add data from here, or if I have downloaded it from there, I can upload it here. Once you have that added into your Kaggle notebook, you can see them here. And then all I do is I click on copy file path, and I just paste it here, right? This is how it looks like. So Pandas is a very, very helpful and powerful library of Python. It helps you convert this CSV into this data frame table that you see. And when I do dot head, I'm able to see the first 10 columns of this data set, how it looks like. Just like what we saw there, these are the column names. The column names haven't changed, right? The thing that we are able to see is the values. What are the values of sale price? you can see there are these values changing. And what are we trying to predict here? That we are actually, in this entire EDA process, we're going to find out what is the relationship that sale price has with, say, pool area, or has with lot shape. If it's a regular lot shape, maybe is the price more, or is it more when it is IR1? So for us, everything here looks pretty much alien right now, but when we progress in the notebook, it's going to look a lot simpler, right? So these are the columns. This is how you can check all of the columns. And whatever you do, you can just, if you do nothing, do go take back from these small things on how to actually see in one glance what happens inside a data set. There is describe, there is info, there is dot head. Do all of this and at least understand how this looks like, right? So describe will actually give you the mean of the entire all of the columns together. And I think there are some times when Kaggle actually gives you that particular this thing, but always feel free to Google every single thing that you see. You can't understand something, Google that part. Okay. So first thing that we can try and go ahead doing is your bar plot. Like we're gonna do univariate first, then bivariate. Okay. Now univariate, let's see. So what I did here was I was looking for something that can be taken from these columns. That'll be something that'll be easy for us to understand. And street seemed to be something like that. But streets seem to have just two of these types. There is paved street and there's gravel street, I think. So GRVL might be a gravelled one or a paved one. So based on that, if I try to plot the sale price, this is how the variation looks like. If it is a paved street, the prices are shooting high up, right? So within just one glance, I'm able to make that conclusion. This is what EDA helps you do. If I try to plot a histogram, here, all histograms, we require a count, right? If you remember seeing it in this house price, inside this, I have these tooltips, which are very helpful actually. So in this, if you see MS subclass, let's look what is MS subclass. MS subclass is a building class. Okay. Now, based on the building class, we have a count of 605 that fall in this category. So this is your sale price, right? Let's see what if that's what happens here. We have done, so we can actually do a histogram for each and everything. I've done it for sale price. I could do it for MS subclass as well. So feel free to create one more code here. Type the same thing, remove the column sale price, type MS subclass and see how that histogram looks like. But if you notice, I have written here one more number inside the histogram. So PLT, I'm sorry if I skip this part. PLT is actually Matplotlib, which I have actually given an alias, which is PLT. So Matplotlib is also another powerful library. Along with Pandas, we often make use of Matplotlib, and we're going to be making use of Seaborn. NumPy is also coming in one of the places because we need to change the arrays. We'll come to that in the dataset cleaning part. SkyPy, again, for more statistics things, we are making use of functions inside that, but I don't think I'm using this. We'll skip this for now, okay? Just don't, there's no need to import these things for now. Let's just focus on these. Seaborn and Matplotlib is for plotting, and Pandas and NumPy and SkyPy are for the problems that we'll be having, the mathematical and scientific things that we're gonna keep adding, like mean, max, min, max, stuff like that, right? So here in PLT histogram, I've given two things. One is the column that I want to print and the number of bins. This number of bins could have been 200, could have been 100, because I don't know. I know that this is a very huge thing. I've got so many columns, and this is just 10 rows out of that. If I do shape, I will be able to see how big this entire thing is, right? Let's do a shape. This is, I think, 1,400 columns, rows. That many sale prices are there. So it is not going to be easy for me to actually figure out in the beginning. For you guys, it might seem like, okay, what does the number of bins mean? It's not running for some reason, but shape is 1,000. We'll see that. I think it's been done for this. 1,400 is the number of rows and 81 columns. So these number of bins, for now, I've just used 50. But in order to choose the best number of bins, that's a very interesting thing to find out. And there are a lot of debates on this, but there's a huge amount of literature for this present here. And I found this Stack Overflow question to actually include those links here. So feel free to go through this. The rule of thumb, there are certain agreed upon standards for choosing the right number of bins in while plotting that histogram. But what we are trying to do is just understand in one glance what does this data set consist of, right? So we are having a bunch of, say, 150 plus houses that have a sale price between 1 lakh to 2 lakh, or 1 lakh to 3 lakh is this. Like, there are very few, and then those that go all the way till 7 lakh is a very small number. These are the kind of interpretations and insights that you want to derive, right? Let's see. Let's try to find out whether we can plot the fourth thing that we mentioned in univariate was a pie chart. So in order to plot a pie chart, I just went to Matplotlib, typed out their, found out what their basic example was for, and we're going to try to plot this. So this was their example. So in order to use this example for our data set, what I did was, I know that I need 4 of this. So what I've taken is the sale price, and this is how you can, from the 0th sale price to the 4th one. This is how you find out just the array of those 4. I use that as my labels. The sizes is my sale price part, and the lot shape here. So basically pie chart can be in terms of it's your affection towards something or not. So regular pie charts, and you can actually have an aggregate of this. So there would be ways to make an aggregate of this. So regular plots could be summed up together, and IR1 and IR1 could be summed up together. So these are the 4 different kinds of plot variation. And there's, of course, one thing that we missed was the frequency distribution graph. Now, frequency distribution graph, most often than not, we want it to be a normal distribution, right? Now, in this case, a normal distribution, it does not actually look like a perfectly normal distribution. A perfect normal distribution will be somewhere towards the center, and it will be having a very nice curve, a bell-shaped curve here, right? So there's definitely some skewness towards the right, and there's some kurtosis happening on this. So in terms of like skewness, is actually written down these definitions for you guys. Like, you need to have a perfect symmetry on the left hand side and the right hand side. Whenever there's a lack, know that there is a skewness. It's leaning towards one direction, right? And kurtosis is that tail that you see. There's a good amount of tail here. So to find out what they are, you can actually do just a dot skew and see how much of skewness is there, or how much of kurtosis is there for your sales price. And I've added some more links to, so everything that I mentioned here will have mathematical formulas. And for all of you who are interested in understanding that in detail, do go ahead and click on these links and read what those formulas are. So moving on, we are now going to do bivariate analysis. We've done a univariate analysis. We've gotten some understanding of how sale price looks like. But there are more variables. Like you saw, there are like so many variables here, and not all of them can be finished within your univariate. So we're jumping to bivariate, where one of the first things we know is if you have 2 continuous variables. Continuous, again, here we're talking about numbers. We're going to plot a scatter plot between them. And let's see, what is this value here I've taken is GR live area. Let's see what was the definition for GR live area. Okay, this is how I want you to use the next competition data sets. Okay, so GR LIV area is the above ground living area square feet. Now, I think countries abroad have basement areas. That's why this is above ground, the square feet that you have above the ground. And we're going to try to plot it along with sale price. Now, be a little keen observant here, because we're going to be changing the look and feel of these graphs. Right now, it is spreading out like a cone. That's a hint I'm dropping. We'll be thinking about learning about more about why this is so and how we can change the shape of this. But it's clearly a linear relationship. So as your ground area increases, your sale price will increase. So if it's like, say, I am currently in Madhya Pradesh, so you have, say, 1,000 square feet ka ghar would be, say, 30 lakhs, or you have 2,000 square feet ka ghar might be 60 lakhs. So similarly, this guy was in US, so I think the data set is also US. That's why you have different. This might be in USD dollars, and depending upon the increase of your ground area, your sale price is definitely increasing. There's a linear relationship. Let's try to plot another scatter plot. But by the way, please try to run these things and see if you guys are having any trouble there. In case there is any problem, feel free to reach out. There are a bunch of chat things happening. I've not looked at it, but we'll take a look at this at 5:30. So while trying to plot it for the next thing, so what is the next thing that I've chosen here is a total BSMT SF. I'm not sure if you remember seeing this. Let's just see it again. Total BSMT SF is a total square feet of basement area. So again, here there is a somewhat a linear relationship in this area. If you can see, I can plot a y is equal to mx, but then there's a curve and suddenly explodes. So it could be partially exponential as well. Okay. Now that was for continuous variables. I can also plot a graph for categorical variables, and mostly it's like when you have one continuous, that's sale price, and one categorical, we'll have a box plot. Now, box and whiskers plot is used in several products. In the past product that we were using for our retail industry client, we had box and whiskers plot, and it's fairly common amongst statisticians. So it would be great if you understand what a box and plot looks like. But first, I'll show it to you, then we'll go to the definition of it. This is what it looks like. We have made use of the overall quality of the variable called overall quality. It's a categorical variable. If it's an excellent quality thing, you do expect the sale price to increase. If it's of a poor quality house, you expect the sale price. Just on the definitions, you expect that to happen. And this is exactly what happens in terms of the graphs as well. But now let's focus on why are we plotting it like this? We could have plotted it by something else as well, but this is a categorical thing. So you don't have values like you would have for total for other things. So let's see, overall. Yeah. Overall condition rating. It's a rating. Now that's exactly what a categorical thing would be like. When if we have a survey and you say you strongly agree or strongly disagree, this is categorical. How do you plot things like this? Is using box and whiskers plot. Now inside this, that box that you see, it will be having things like this. So let me just take you through this. These are very helpful links. Let's see this. So this is what it looks like, right? You have the definition always happens as in from the bottom to the top is where you start naming everything as quartile 1, 2, 3, and 4. So if you see a sale price of 7 lakhs here, and you see it from here, so you basically are able to say that 50% of your this thing is above a certain range. So you need to say that this is your 50% and this is your 50%. Or if you're able to see, let's say, yahan pe, there is a 75% directly being taken. This is the quartile here, right? So it's always in terms of 50, 25, 75, 100%. It's in quartiles, okay? And the first one is at the bottom. Please remember that. 1, 2, 3, 4. That's how we mentioned it. So that's why you have your lower whisker as your quartile 1 starting. And like this is called the whiskers. This is called the box, right? And there'll be some outliers as well. There'll be some of those dots as well. So it's pretty clearly written here where you have your median data where this is the midpoint of that data. Everything will have that midpoint. The rating that's given, the overall rating midpoint would be given there. And that line divides the box into two halves. Okay? Now you have the interquartile range, which is actually mentioned as 50%. Okay, upper quartile, everything's been defined here, but do go through this in detail a little bit because they have real world applications and it's not just in the competition. 25%, like I mentioned, the lower quartile. You have 75% is all of this together. That's the upper quartile entirely. Next is the whiskers, right? So it could be outside. Whiskers are usually that outlier part, right? Those dundies, those sticks that you saw. Now to interpret them, let's use the Khan Academy thing, which actually is very helpful. So I would highly suggest you guys, if you have any math or statistics doubts, do go to Khan Academy. They have amazing courses on this. If you really want to learn through videos and problem solving things, practice material is very, very nicely developed in Khan Academy. So here in this case, let's take out this one. I had done interpreting the quartiles. So we have a box of raisins here, and what percentage of those box of raisins are weighed more than 29 grams? So if you see inside your Q1, where is 29 coming here? In between 28 and 28 and 31. So if you see, this is where somewhere here is where you see this. So since your Q1, the first quartile, Q1 is equal to 29. 25% of the data is lower than 29, and 75% is above 29. That's how you interpret this. So that's how you're going to see your sale price as well. You take a number from here, and then you say, okay, this is falling under this particular quartile, and that is why my 25% or my 75%. That's how you read this. But please do go ahead the entire thing for a proper understanding this. I've just plotted it for one of the categorical variables. The other thing I found was year built. So one thing I could definitely understand in this, the process is similar. PLT subplots. I've been using the same set of things. And here I'm using Seahorse. Seahorse is the thing that I've used. Subplot is just basically to draw this thing, and Seahorse is the library that provides us with the ability to plot a box plot. And I've given in the x-axis, I've given the variable name, which was the overall quality. The y-axis variable against which I'm plotting the continuous variable is the sale price. And the data is our data set. So I've given data as my house prices data set. I've taken just that particular variable. Those two variables actually, I can actually take in. So Pandas is actually helping us create just those two things by concatenating those columns out. We're creating it, concatenating on the axis 1, make that one particular thing as the data, and I'm sending that in my Seahorse box plot thing. So the same thing can be used for, I pluck out year built data here. So that is the house prices variable that's taken out here. I've taken sale price here, concatenate, make one data, and then I send that exactly here. I've just given the x-axis variable and the y-axis variable. It's also plots box plots. So what I can definitely see is sales price has seen an increase in the newer years. So this is 2010. This is 1872. Okay, so there's a lot of years in between, and there has been an increase in this, right? There's definitely you have like very small boxes as well here, so their prices were pretty low. They did not vary a lot. Here there are different variations between this, but as you go new, older relics did not have a lot of price, but that's how it moves on. So we have been looking at different kinds of plots. Let's take a summary of this. We've taken the scatter plot, and we've taken the box plot. So in a summary, we did see that there were these two. The area that we have in our above the ground and in the basement, there seemed to be an increase in sales price. Both of the relationships are positive, which means as it increases, the sale price also increases, right? Now, overall quality and year build, one that we use the box plots for, again, we have a very strong linear case. Like as your year build is also increasing, you see that there's an increase in the sale price. Overall quality made it was a little bit more clearer, because as an overall quality increases, this is increasing. You also see a increase in the size of the boxes as well, right? Now, these are just 4 variables, right? But we do need to understand there are a lot more variables to go through. So there is 5 more minutes to go, but let's see. Since there are several variables to actually predict our target variable, we have to act a little bit more smarter and take a bird's eye view and take a look at this entirely. So we're going to plot a heat map directly, and this heat map can be plotted again using Seahorse, and the heat map requires something called correlation metrics. The correlation metrics, we'll get into that. So this is what it looks like. I don't want to confuse you at all, but I have all of my variables here, right? And all of my variables again here. So I'm actually finding a correlation between between every variable and every other variable, right? So if you guys feel that that's confusing, this what I've done is I've just plotted that correlation matrix here. There is a scroll bar here that's gone, but it's the same matrix that you see in color there. You can see there's a 1, 1, 1 here in the beginning, and in the middle, in the diagonal, and that's the white line that you see here. Okay, this is basically because I'm plotting ID against ID. So that'll be 1, right? MS subclass against MS subclass, that'll be 1. They are completely correlation, like they are correlated completely, right? For those of you who have no idea what I'm talking about in terms of correlation, like you did understand on what linear relationship is, right? So correlation can either be 1 or it can be -1. That is positive correlation perfectly or a negative correlation perfectly. If you have negative values as well, you have positive values as well. But it's between 1 and -1. That coefficient value will always be between 1 and -1. So you have this entire range that it can come into. And that is why you see all of these numbers between 1 and -1. So, but when it's in the all the way to 0, it is in a positive. And then if it is a 0, there are cases where you could have no correlation between those variables, and you have a 0 and there's no correlation. It's just passed. And here you have negative correlation, high negative correlation, and perfect negative correlation. So, but also definitely go understand that the very cliche thing that you always see is correlation is not causation. And for example, this is also a cliche example, but you know that the sales of ice cream is going to go high up in summers. And you also know that there will be a lot of sunglasses being used, but that does not mean that if you're wearing a sunglass, I would want an ice cream, right? There is no correlation between rising sunglasses curve and a rising ice cream curve. So correlation is not causation. But in terms of this, because we've just analyzed 4 of them, I wanted you guys to have a quick overview on how are all of these variables related to each other. Is there any correlation between them? And since that plot is really huge and we have a certain similarities, but the gradient thing is too pixelated to actually understand what is their color, this thing. So we're going to zoom in, okay? And the next thing what we're going to do is we're going to zoom into one particular thing, because sometimes you feel the colors will be similar, and we might have to plot in, like, let's try to zoom the largest one possible ones. So inside the correlation, so a correlation matrix can be directly just understood by you give a data frame, you use .corr and call that function, you get a correlation matrix ready for you. Inside this also, within these numbers that you see, what I'm going to do is find out the largest values. Okay, so you see here what I've done is n largest in regards to what? The sale price. And I've taken, let me focus only on 10 of these variables. So I have array of these 10 variables that have been returned with the largest. So these are the columns that I'm going to focus on. Here is where I've used NumPy. Remember, I had imported NumPy as NP. So in this, I'm going to find out what my correlation coefficient is for these particular 10. We're again zooming in because we can't go through everything. So we're zooming into these set of things. And again, I've drawn a heat map, just like how we did for the first one. We'll just finish this part and then we'll stop for a bunch of questions. So here, if you can zoom in, let me just increase the size here. If you see garage cars and garage areas, they almost have a similar trend. And like you have these twins, basically. You have these numbers which are actually repeating. If you see this and this 0.610, 0.610, they begin with similar colors. This is what I meant by there might be things that are very close to each other. So what happens is you don't have to look at the other one. You look at just one. So I've written down the summary here is overall quality, great live area, and total basement square. They are strongly correlated with sale price. And garage cars and garage area, like how I mentioned, these two things, they have pretty much the same numbers. Okay, there's just one decimal difference. There's just one decimal difference. So if you actually think about it, the garage area is, so if you have a certain area for a building, that is the number of cars that can actually indirectly tell you how many cars can fit in that particular garage area. So you don't have to individually look at them separately. They are twin brothers or twin sisters. So you just have to look at one of them. We are trying to reduce the number of variables that we have to focus on to predict the sale price, right? Similarly, like how we saw here, these two are twins. So these are the ways you actually reduce your work, act smart. And then there's total RMS square area, I think, above ground. And again, so I've listed down these things, and this is how you zoom in. Once you've zoomed in, there again, you've had reduced a lot of your work. But there's one more thing that you can do is do a pair plot. Now, Seahorse is like one amazing library that in one line, I'm able to plot these many graphs together. So pair plot, what it does is you have a histogram in the diagonal, and you have a scatter plot in the above the diagonal and below the diagonal. Now again in this, you have to notice certain graphs. Like if you see this particular thing looks like a perfect cone, right? You have the same thing being plotted here. That's against great live area and the total BMSTF. There's also the same thing being plotted here. So that's where you see below the diagonal, and there you see above the diagonal. I think there was one more thing that I wanted to show you was the year built versus the sale price. So this is actually going to give you a understanding on how most of them actually look. You can see that linear relationship. A lot of them have linear relationship. A lot of them seem sparse and very useless variables. But these are the ones that are like, you can see in one shot, you can see this, and that has happened through just a single line of code. So this is again, but we've used only those set of columns that we know are useful based on our correlation metrics that we used earlier. Okay. Let's just pause now because this is one part of the things that I've done for house prices. We can move on to the happiness index as well, but there is more to describe on what more we can do. Can we just have a quick check on any questions, anything that has to be urgently answered? Kartika, is there anything else?
Yeah. So there are two questions which I think you can answer right now. There was one question. So is it possible to convert categorical to numerical? I think Asha tried answering that in the chat, but maybe you can also take it up.
Yeah. We are doing one of that, I think. So there are cases when you end up having categorical variables that might say have 0, 1. Okay. There was a case where we had to actually predict what are the most important features that should be sent into an algorithm. And before doing that, what we used to do was in ElasticNet is what we used. We should transpose that matrix. You all know what a transposing of matrix looks like, right? What is rows becomes columns, what is columns becomes rows. So instead of having just 0, 1 for that particular as binary values, what we did was we made that a numeric variable, and we made dummy values being filled in. So it is possible to convert into numerical. I was just checking if I've done that for one of the cases here. So in terms of the use case, you definitely end up converting and transforming data. There are a lot of transformations for your data. The more you can keep squeezing your data to get you the truths that you want, but always keeping in mind what your objective is, and it is possible to transform that. Yes. I'll just see if it's there in this notebook. If it's not, I can share an example of that as well. In one of these things, we can do that. Anything else?
Yeah, just to add on that, someone was asking, is it similar to one hot encoding? You can answer, maybe I can also answer.
Go ahead, answer.
Yeah. Okay, so I just want to make you all clear on this, that categorical and continuous, these are two different things. Categorical is discrete, and continuous is what is continuous, and which is basically numerical. So don't confuse these two things. Now, if I understand from this question, converting categorical to numerical, what I understand is it's encoding. So, for example, categories are cats and dogs. So you can now, if you want your model to understand, if your model just takes in numbers and it cannot take in text, then you have to convert into numerical. So you can say dog is 0 and cat is 1. But you cannot convert this category into continuous. Okay, so because there's nothing in between cat and dog, right? So I just wanted to chip in here so that you don't get confused when we say converting categorical to numerical. It depends on the use case. Yes, when I told converting categorical into numerical, like converting dog into 0 and cat into 1, that is same as one hot encoding. So you're right, Priyanka. After which there's another question. On the same note, you can convert numerical to categorical. Like for example, you can bin it. So let's say all the numbers lying between 0 to 5, they fall into category A, and all the numbers between 5 to 10 are in category B. So that is possible. That is basically called binning. The next question we have here is, later on, are these correlations between the two variables, will they affect accuracy of model? I think this question is coming from the point where you showed those heat map correlation, right? So if the two variables are correlated, then I mean, does that affect accuracy of the model?
So accuracy of the model is a later question, because currently we've not even decided on what the model is going to be based on, what algorithm we are using. And I think the accuracy part is going to be covered in a lot more detail, and that is more based on what the algorithm you're going to use. But definitely you can reduce the amount of time and that you spend. The model will be like, okay, if you give totally uncorrelated values things, variables into the model, it will skip it. Eventually it might skip it, like elastic will just skip it and then take the ones that are actually correlated and then find something out of that. But accuracy improvement, I think it'll reduce your time if you remove them earlier on. But if your accuracy is more on hyper tuning parameters, all of that is going to come into our classes in the upcoming days. Kartika, do pitch in. I think
Yeah.
I mean, you do a hyper tuning parameter, all of that part happens, right?
Yeah, you're right. You're right. So I mean, it's just for dimensionality reduction, where
Correct.
we are seeing correlations and removing the variables. So there's another question, that can we eliminate features just based on EDA? For example, features with no or low correlation with the target. Similar question.
Yeah, I mean, I think we answered that. Like we do want to zoom in and try to find out what are our answers, but these pre-processing things can be avoided. The entire thing can be sent in directly. And later on, there have been cases where we have had to, like, okay, it's taking a lot of time. Let's, instead of sending 500 variables, let's just find out what are our correlated ones and what are our most important, drivers for this entire model, and send those in. But so EDA itself can be skipped, right? So sometimes we just give the entire, all of the features. Now, once you've figured out that there is no correlation, you can choose and not to, but it all depends upon the objective. Sometimes the client would be like, no, everything is important. Please, I want a study or a report based on everything. Don't eliminate features. So it will vary. You have to make the choice depending upon that objective thing of your question. Is there anything else?
Yeah, I think that's it for now from the question side.
Cool. Yeah, feature engineering. So let's just move to the next data set, but we will be using the house prices in between also. We can actually, you guys can go ahead and try out what we have done. The same process we are going ahead, and it's just another input data I've taken. Same process is being used. I'm taking, like, there is 2019 and there's 2015 as well. This is a little bit more simpler approach to this because this was just a data set in Kaggle. We did not have competition, and there's no objective here. It's just a plain exploration here. So I'm just trying to show you some more plots as possible, along with seahorse and all of this. There's again histogram. You go ahead and try out these cells again. Just click run, and find out. Try removing these things. See what the error comes in. Understand why exactly these things are, and please do read the documentation. And because every single thing, Matplotlib, Seahorse has amazing documentation. They have examples how to use every single function. So go ahead and try out these things. So one thing that I wanted to just show was, here we're trying to plot a regression plot. Okay. Here, this regression thing is trying to plot it between the social support and the life expectancy. It's basically showing you how happy you would be in different countries. This is a data set that has a happiness score for every country, and just there's like Finland is on the top with a very high score of 8 or almost 7, and India is somewhere at the bottom with 4. Kind of expected, but it's a fun way to go ahead on this. But I do want to tell you that sometimes regression, though it's very simple, might not exactly help you understand what that data is going to, is it actually having any correlation from that regression plot? If it's a straight line, is it going to be positive relation, negative relation? Sometimes it's really hard. And just wanted to put this XKCD cartoon out here. Do go and check out XKCD if you've not already. But I'm a huge fan of this. It actually clears out concepts as well. We're moving to the last part of our workshop for today. And that is also a part of one of the micro courses that Usha shared yesterday, the data cleaning part. Rachel Tatman has a 5-day workshop only for data cleaning. So highly recommend that. I've given a link for that. We're going to look at 3 things that we can do after having done EDA. We can do a pre-processing, that is the cleaning of these things. Missing values are what we're going to find out first. So here you need to understand sometimes some variables, okay, will have missing values. Now, based on that name of that thing, of that variable, you might actually have to figure out a little bit more, have some common sense here and say, does it actually not exist or was it not recorded? Remember, like I mentioned, that there are sensors on your tires, there are sensors on your inhalers recording these data points, right? But there are sometimes there could be some scenarios, say scores or sports, when you're doing sports analytics. ESPN does a lot of sports analytics, so there might be some things that are not recorded. Not because it does not exist, but it was just missed on this thing. But there are something that just don't exist. So find out and use your intuition here. You have to understand what process comes into collecting that kind of data. Like I have added landslide data here. There could be some things that are missing here for a reason, and see how many points we have. If there is a lot of missing values, you might not be able to proceed ahead. You have to find another data source. And sometimes you can go ahead and drop those missing values and still progress further, because there's the percentage of missing data is very less, but you still have an 80% of your data set remaining. You can go ahead with that. That cost is pretty less. You're not missing out on much. And sometimes what you can do is, if something is missing, you can fill in values, and that is called imputation. It's somewhat a better option. So let's see what happens in this. This my data here is referring to the happiness data that we've taken above. We have imported that data. And inside this, when I tried to find is null, is there any missing value? There were no missing values. Perfectly set up collected data. But when I went to the house prices one, we did find a lot of missing values. So as you can see, the way I'm trying to do is I first sorted this. I found out how many null values are there. I created a sum, found the percentage of missing values for every set of column that we have. And this is the percentage of missing values that we have. Everything has a certain amount of this, but there's not a lot. Okay. And some things are a lot, some things are less. Now, if you see, there are 81 columns here. Now, like I mentioned, the first strategy would be to drop out these missing values, and you can keep track of how much is lost. So, like I told you before, 1,460 rows are there, but 81 columns are there. Now, some of these values actually had a percentage of 99. Like, there's a lot of missing values. You remember seeing a lot of NANs in the starting when you did a head 10. There were a lot of NANs. So some of those we're going to remove directly, and Pandas allow you to just drop off those columns that have a missing value, which is greater than 1 here. And we've done some more things. And then finally, we again check for, after having dropped all of those things, we are going to check whether there's anything more missing. And ideally, this should be 0 after you've dropped all of those missing things. So if you see now, the number of columns is reduced from 81 to 63. So that many columns have dropped. The next thing that you can do is you can actually go ahead and, so like I mentioned, you want your data to have a very nice bell curve. Sometimes your data might be skewed on towards the right. So you can try to make use of some transformations, but this might be a little hard to explain. There is something called box cox. This is again a statistics function that allows you to do this. So we can transform our data that looks like this, change their scales, and normalize this data. I will be adding a link to this. I think it's missing in the notebook that you guys have added there. The next data cleaning part we can do is, if we had dates, like some of these would have dates here. I've used the landslide events data here to allow dates to be seen here. Like if I click on this, I think you can see it here. This is one thing that I really liked about Kaggle. It shows you, if you just click on that data, you can see. So here you have date as one of the columns, and they are not in the normal hyphen format, right? So what happens is, if you can see, I am trying to simply get what day it is from that date. Okay, having done nothing, if I just go ahead and try to find what day of the month that particular landslide happened, I would end up having errors like this. That there is nothing present as a date time like value. So what I'm going to do is pass those values and change the format. How to change the format? You give a format by using the pandas function called toDateTime, and from this landslides data frame, I've picked up the column date. I've given this format that please follow this format and create that past value. So now I can see the head out of this from what was looking like this has now converted to a proper format. If I try to do on the past data set, if I try to again find the date, day of that particular date, I will not have any problems. I can directly get what dates, what day of the month that landslide had occurred on. So there is no problem in that passing. These are the few things you can do: drop missing values, change the date structures. And there's some assumptions that you should definitely check out for. Like I've repeated this quite a lot, that your data should look like a good normal distribution. What this allows for is it helps you get rid of problems like what we assume is that even when the errors exist in linear regression, we expect the errors also to have a constant variance, and that's like an assumption that we have, and that assumption is what is called homoscedasticity. And when we violate that assumption is these, so when I talk about errors, it's this distance between this value. So these errors also we think are having constant variance. So when you don't have that constant variance is when you have something called Heteros Capacity. So there is this book written by Hare. I'll be sharing the links, Amazon links of this as well, where this definition is meaning where you expect that all of the dependent variables and the errors, everything has a very constant level of variance across them, across these variables. So homoscedasticity is desirable. We want that error term to have same to be same across all the independent variables. But when that does not happen is when you have the heteroscedasticity problem. So once we have our data looking normal enough, we avoid that problem. Okay. Another thing that we often look for is linearity. Now in house prices, what we saw was, if you remember the pair plots that we did, most of the things were having a linear trajectory, right? You remember as you have an increase in this thing, you have a lot of linear things, right? There's a lot of linearity. So linearity is an assumption that we expect to have that. So we're not going to solve for that here in our house prices thing. But now there is something that you can go ahead and check out is the third part in the data cleaning part is, let me just solve the normality part. After that, there's a switch in the orders. Okay, let's just cover this. So there's something called scaling, and like how you saw, there can be cases where you want your data to lie between a certain range 0 to 1, so that your end result, or maybe you want to be on a larger scale, you can increase or decrease that scale. Min-max scaling is what I've used here, and I've added a link to this particular blog that explains everything about min-max scaling, the one that we are importing here from ML Extend. And in this, what we have done is basically we've used an array that looks like this, and we are going to be scaling this particular data to just map what does scaling that mean. You're going to take the same thing and then plot it on a scale of 0 to 1. Like if you want it between 0 to 1, that is how that data is going to look like. Okay, that scaling is going to look like this. The original data is pretty less here, and we're going to zoom into 0 to 1 and plot the same thing there. This is how you can plot these two things together. Is these arrays that I've exactly taken this array and this array. I've used NP to create a random array of these numbers, used min-max scaling on that, and then made it come between 0 to 1. So that is how. So this 2 were changed to something here in 0 to, between the 0 to 1. Okay. Every data will also have outliers. Like I mentioned earlier on, that there is a company called Eugene AI. They detect anomalies and outliers out of any data, and they warn you about it, because once you have outliers, there are times when you might spend more time figuring out why is this having a different value from everything else. So it is kind of important to try and remove those outliers, or at least understand, okay, this is an outlier, this is how it is. Inform your team about this, and you do something that's different from the rest of the things that actually follow a pattern. So you remember when we are plotting the great live area, there are these things where they are complete outliers. This is the entire group, and this is like standing outside this, right? So inside this, if you were to remove that particular thing, I have actually found out the exact point of this, where it is inside the data, and I've removed that. I've dropped that particular index and then plotted them. So what was on 5,000 here, I just removed that, and now we don't have that in our plot. So there is definitely more things that you can remove from that, but we leave it for that now. I'm just saying that when you see outliers, it's possible to remove them and focus more on what is following a certain trend. Now, as we mentioned earlier above, is norm. We want to try and make everything a normal graph, and inside this, what we can use is a histogram and a normal probability plot. Now, a normal probability plot is, please go and check out the documentation of this properly. What it does is helps you plot the probability distribution and also this across the theoretical values. So we're going to listen more about what the interpretation is, like focus on the interpretation right now. Because this is very, very direct. I can explain this in detail later on if you guys ping me. Here, if you can see, what I'm trying to plot here is the sale price. Does the sale price look exactly normal, or is it actually deviating from that line? So this is the line that I would want to look, exactly. It should fall straight on that line, but it is not. It is going up, and some parts are like going towards, it's like a U shape, right? So what I've done is I've applied a log transformation here on the sale price thing, and I've plotted the same thing again. When I do the same thing again, it looks pretty normal. Once it looks normal, what are we trying to avoid is all of those initial assumptions that we did not want to violate. Similarly, let's try to do it for great live area. Again, I'm doing the same thing. Draw plot. I plot it here and I check out what is there. How does it lie across this? So let's do a log transformation on this again. We're doing a data transformation here. And again, when you try to plot it, it tries to magically put it along this line. So as in when you see this happening, you are actually trying to make sure that it is following that homoscedasticity and not having heteroscedasticity, right? The other thing that we wanted to address was, so heteroscedasticity. So also, if you click on this link, Geeks for Geeks actually explains, when I mentioned that in our pair plots, we saw a lot of things that were following a cone structure. Yeah, this, instead of scrolling, I thought I'll just click here. If it is following a cone structure, know that there is something wrong with this, right? You want it to have a very homogeneous structure on this. Everything should be in this part. Like it should be looking somewhat satisfactory in terms of this. So whenever you see this in your scatter plot is something you can do very quickly, right? So between any of those things, if you see a cone structure, you need to make sure that you have removed that. Now, when we try to, after having done all of these log transformations, when I try to plot this, that cone structure is gone. Okay, that cone structure, if you scroll right all the way up, you do and see that it was a cone before, like this. Now it has come almost, it is looking very, very homogeneous in this case. And I would encourage you guys to practice all of this on more data sets that I've added here. There's World Bank data, and just feel free to just explore the world of Kaggle. There is a bunch of data sets and competitions before you jump into the WiDS Datathon, or jump straight right in. There is no issues. You can do a lot of exploration there as well. And make sure you do attend the upcoming series workshops that we have, because we're going to learn in detail how to select the right features, how to select, do feature engineering, how do the right model selection. And there's also neural networks, which is one of my favorite topics, and Karthik is going to be taking that. So we're going to solve one of the previous year's datathons also, the problems itself directly. So that is going to help you out very nicely, understanding not only neural networks and CNN and all of that, but how to solve and submit and all of that. You've understood that yesterday, but we'll do that entirely once again on the 5th day. Stay tuned and do let us know if you have any doubts. Regarding the teams also, if you have any doubts and on creating this thing, I urge you guys to just make those teams. Go ahead, make your own teams over and over. If you find everybody's made a team, then you can just club and send merge requests for those teams. Okay. Any questions? We are having just 4 more minutes to go. Sorry I had to rush in towards the end, but this notebook will be available to you. You can connect with us on WhatsApp as well. Post this, I will be able to answer. Sai Verma data cleaning session. I have added the link here itself. It is there in the micro courses also. If you have the, let me just paste this.
Yeah, few of them are not able to open the link, Julian.
For the data cleaning alone,
This entire notebook, the notebook link, you may want to paste that again.
okay. Share, copy. This is the second one is my notebook. The first one is the data cleaning link alone, where it is a 5-day workshop itself on data cleaning. It is very rigorously done. Everything has been taken care of in terms of standardization, encoding, and inconsistent data. Highly recommended, because it's Rachel Tatman. She's done a great job in explaining that, and she was also given you a lot of practice courses as well. So feel free to practice on that. Any other questions? Is anybody having any other trouble? The page is not working. Page not found. Okay. Can you try via incognito? Because, or else maybe you have to log in and log out of. One of the WIDS ambassadors, can you guys try?
Yeah, it's for us. Yes.
It's working for you guys? Okay,
Yeah.
then
It gave me 404 once, but then I reloaded again and then it worked for me.
let us know. Otherwise, we'll connect with you, Sai.
You're
Yeah.
checking multiple browsers too.
Kaggle should work and everything, but
Everything,
let us
right.
know if there's any issue.
And there are a few questions too, Julian. You may want to take that up.
Is there a data set that shows how to deal with imbalanced data? Imbalanced data, I can try to find, but none on this. I think house prices did not have that, but I will try to find this out for you.
Yeah, I think Rinky, her session, which is I think the 4th session, she will be covering this part, how to deal with imbalanced data.
Okay, perfect. So guys, do keep coming. We'll have more of this discussed. I think code is the same link, data link cleaning session. Any other questions? If there are huge, do we always drop out the missing values? Sometimes we do replace the missing values. Yes, that is called imputation, and it is being described very well in that link that I shared earlier. It's there in one of these. Wait, I'll just take you to that. So it's above here. So go to this link here in data cleaning link, Priyanka. Here you have a very good information about imputation, and it is possible to replace. So sometimes what we do is we try to find what is the column just presiding this column where you have missing values, and you will replace the missing values with what was there in the column right next to it. There are a lot of strategies to do imputation. This is one of them, but there are others that have been mentioned here. It will be taken in detail in this notebook. So like I mentioned, this itself is a 5-day challenge thing. So every day we can actually spend 2 hours dealing with missing values, 2 hours for scaling. I could only introduce you to the topic here, but there you can actually spend more time doing this. Any other questions, or else it's 6 o'clock?
There was one question: do we always drop out the missing values? Sometimes we do.
Yeah, I just
replace.
answered that. Yeah, I just
All right.
answered.
Julian, I have one question. Does imputation lead to biases in the model?
A lot of things can lead to the biases in the model, but imputation, so depends on your objective also, right? Supposing you have added specific values only, values that have a certain set of values only. Like say you added all tens there instead of having added a random set of values from random number of columns there, it could add in a bias. And model ke andar there are multiple places where bias can creep in. The sample that you take in, the way you treat this, it could be possible, yes. Others can also feel free to answer this. Where, how do you go into each of this?
I think link is not working maybe. So another alternative is you can add this whole code into your GitHub and share the GitHub link also if they're not able to access through Kaggle.
Okay, sure, I can do that. I'll take a download of this IYPNP and upload it into GitHub and share that. That is also possible, yeah.
Have you logged into Kaggle before trying to open this link?
He has logged in. We'll help you guys. Sai, let's connect offline and we'll help you out. Yeah. Let me just share this directly. Okay, guys. Tune in tomorrow. Sorry, on 30th is our next thing. So let us know if you guys have anything else to be addressed meanwhile, and we'll meet on 30th. Okay, thank you.
Okay, thanks, Julian. Bye.
Thank you.
Thank you, everyone.